Hey, welcome to The Explainer. Today, we're going to talk about something that can make your computer feel like 100 times faster: storage caching. It's this secret weapon that a lot of people don't totally get, and we're going to see how it turns those frustrating performance bottlenecks into super highways for your data.
All right, so let's kick things off with the problem that I bet sounds familiar. You go out, you get this beast of a server, powerful CPU, tons of RAM, but it still feels sluggish. Applications are laggy, and you're just not getting the performance you paid for. So what in the world is going on? Well, the culprit is almost always a hidden bottleneck in your storage.
So, that bottleneck, it's all about the massive speed gap between your lightning-fast processor and those much slower mechanical hard drives. Think about it like this. You've got this super genius who can think a mile a minute, right? But he has to get all his info from a librarian who, well, let's just say, takes their sweet time finding the right book. That genius is going to spend most of his time just waiting. That's your CPU. And that waiting is what's killing your performance. So how do we fix this? Well, modern systems have a super clever trick up their sleeve. Picture a chef in a crazy busy kitchen. Now, if that chef had to run to the giant walk-in pantry in the back for every single pinch of salt, dinner service would be a total disaster. So what do? They keep all the stuff they use constantly, the spices, the oils, the prepped onions, right there on the countertop for instant access. That countertop? That's the cache.
And that right there is exactly what caching is. It's all about creating this small, temporary, but incredibly fast little storage area. The system is smart, and it puts copies of the data it thinks you're going to need next into this cache. So the next time your app needs that same piece of data, boom, it's pulled instantly from that super fast cache instead of having to go all the way back to the slow main storage.
Okay, so where does all this magic happen inside a server? Well, the very first place you'll find it, the first line of defense really, is right on the RAID controller. That's the card that manages all your hard drives. And it has its own dedicated high-speed memory, or RAM, that's ready to jump into action.
Yeah, this RAM on the controller, it's basically the brains of the operation. It acts like an intelligent traffic cop standing between the server and the actual disks. When the server wants to read something, the controller quickly checks if a copy is already in its fast RAM. If it is, it serves it up instantly. And when the server wants to write data, the controller can just grab it, stick it in its RAM, and tell the server, "I got it," letting the server move on while the controller slowly writes it to the disks in the background. It speeds up everything.
Now, when it comes to reading data, these controllers are pretty smart. They don't just sit around waiting for instructions. They use these predictive strategies to try and stay one step ahead of you. And one of the most effective is called adaptive read-ahead. The whole idea is actually pretty brilliant, and it's simple. The controller is watching how you're reading data. If it sees you're grabbing files one after another in a sequence, like when you're streaming a video, it goes, "Hey, I bet they're going to need the next piece in a second." So it just goes ahead and grabs that next chunk of data and puts it into the cache before you even ask for it. So to you, it feels like there's no waiting at all. Okay, so read caching is pretty easy to wrap your head around. But write caching, well, that's where things get interesting. This is where we run into a really big trade-off, a fundamental choice we have to make between getting the absolute best speed or guaranteeing the absolute best data safety. And this slide just lays it all out there. First, you've got write-back mode. Here, the controller basically shouts, "Got it," the second the data hits its super fast RAM. It's blazing fast for the server, but it's kind of lying. The data isn't actually safe on the disks yet. Then you have write-through. This is the honest one. The controller waits until the data is physically written to those slow hard drives before it says, "Okay, we're done." It's way slower, but your data is totally safe.
So right about now, you're probably thinking, okay, is there any way to get that insane write-back speed without, risking all my data if the power blips out? And the answer is yes, and it comes from this tiny, unsung hero of the server room.
And here it is, the battery backup unit, or BBU. Think of it as an insurance policy for your data. It's this small battery that's plugged right into the RAID controller, and its one and only job is to keep that little bit of RAM on the controller powered up if the lights go out. This gives the controller just enough time to flush everything from that temporary cache down to the permanent safety of your disks. It's a lifesaver.
Now, this is super important, so listen up. If you want performance, that BBU is not optional. It's not a nice to have. The controllers are smart. They know if their safety net is gone. If that BBU fails or if it's just dead, the controller will automatically protect your data by turning off the speedy write-back mode and forcing itself into the slow, safe write-through mode. Seriously, if your server suddenly feels like it's wading through molasses, a dead BBU is one of the very first things you need to check.
All right, so the controller's RAM is super fast, but let's be honest, it's pretty small. So what's the next level up? Well, we can create a huge second layer of cache using something that's way faster than hard drives, solid-state drives or SSDs. This idea is called SSD caching, and what you're really doing is creating a hybrid storage system. You use a couple of fast, pricier SSDs to act as this giant front-end cache for your big, cheap array of spinning hard drives. The system is smart enough to figure out which data you use all the time, your hot data, and it moves that stuff over to the lightning-fast SSDs, while all the cold data you rarely touch stays back on the hard drives. Now, to make all this work, companies came up with special technologies. A really well-known example of this is a technology from LSI called Cachecade. It basically lets you create what they call a level 2 cache with your SSDs. Of course, other companies have their own versions, like Intel with its virtual RAID on CPU, or Dell's version on their PERC controllers. They all work with the controller's smaller level 1 RAM cache, creating this tiered system that just massively boosts the performance of your entire hard drive array.
But wait a minute. What happens if one of those cache SSDs dies? You could lose all that important hot data, right? That's why you have to protect your cache itself by putting the SSDs into their own RAID array. The most popular choice is RAID 1. It's simple. It just makes an exact copy of your cache on 2 drives. If one fails, the other one just takes over. No problem. If you want even better performance and you've got at least 4 SSDs, you can go with RAID 10.
Okay, so we've talked a lot of theory here. Controllers, batteries, SSDs. But what does this actually look like in the real world? Is it really worth all the fuss? Let's take a look at the numbers because they really tell the story. Whoa, okay. These numbers are pretty staggering, right? Your regular old hard drive array, you're maybe getting 500 IOPS. That's input-output operations per second. Not bad. But just turn on that little bit of controller cache in write-back mode, boom, you jump 5x for writes. But then you add an SSD cache for your hot data, and the performance just goes to the moon. We're talking 100 times faster, maybe more. It's not even in the same ballpark. All right, so let's wrap this up with a quick look at the pros and cons. On the pro side, it's a no-brainer. You get this insane performance boost. You actually make your hard drives last longer because they aren't getting hammered all the time. And it's a pretty cheap way to get SSD speed out of your big hard drive array. The cons? Well, it's a little more complex to set up, and it costs a bit more for the extra parts. And I'm going to say it one more time, there is a real risk of losing data if you're using write-back without a good BBU. So, at the end of the day, caching isn't just some little add-on you can ignore. It's really a core technology. It's what bridges that massive speed gap we talked about at the beginning. And it's what lets your hardware actually live up to its potential, making everything feel fast, snappy, and efficient. So here's the big takeaway, the final thought I want to leave you with. Your data can be faster than it's ever been before, but you have to ask yourself one question. So go ahead and embrace all that amazing speed that caching gives you, but always remember that tiny little battery that makes it all safe. Thanks for watching The Explainer.